Hi, Daily Host students. Mr. Kaczynski with you. 6.5 practice your skill exercises from our book dealing with exponents, looking back with exponents, the division property of exponents. Let's do it here. Number one really lays it out for us. Eliminate factors equivalent to 1 and rewrite the right side of the equation in simplified exponential form. So when they say eliminate factors equivalent to 1, they're saying that x divided by x is 1. So we can eliminate that. And x divided by x is 1. And y divided by y is 1. And this y divided by y is 1. I just did AM duty. My hands are shaking a little bit still. And y divided by y right here is 1. So what do we end up with? We end up with these three x's on top, also known as x cubed. And we end up with this one single y, which is just y. So x cubed y is the simplified exponential form. Also, obviously, rewriting it like this, we know the division property of exponents states that when you're dividing numbers of the same base, x and x, you subtract their exponents. 5 minus 2 is 3. When you're dividing numbers of the same base, y and y, we subtract their exponents. 4 minus 3 is 1, right there. All right, number two, you use the properties of exponents to rewrite these expressions. Okay, so here we go. We're going to do 7 to the power of 12 minus 4 is 8. Again, they have the same base, 7. So if we wrote this out like we did in number 1, there'd be 7 or 12 sevens along the top, 4 sevens along the bottom. 4 of them would cancel each other out because they would be equal to 1. And so we end up with 7 to the 8th. Let's check it just to make sure. 7 to the 12th divided by 7 to the 8th. We're not going to do this every time by any means. I'm sorry. I wrote that down wrong. How about this? 7 to the 12th divided by 7 to the 4th. That's a big difference. There it is. About 5.7 million. And then we'll do 7 to the 8th. That's the same number. So we did that right. I guess we could write that out as that number now, but I'm not going to do that in this case. All right, next up. X to the 11th divided by x to the 5th. When dividing numbers of the same base, x, we subtract the exponents. So that's x to the 6th. And remember that we can check that. We can just pick a number, assign it, or store it as x. And then we can do x to the power of 11 divided by x to the power of 5, and that would be the same as x to the power of 6. And even if we changed what we have x stored as, say I make it -2, now I can do x to the 11th divided by x to the 5th, and that would be the same as x to the 6th. So a great way to check our answers. All right, on this one, 12 times x to the 5th over 3x squared. The first thing I think we need to do is just remember that's 12, which can be written as 4 times 3. And then we have these common factors here. A lot of people make the mistake of doing 12 minus 3 is 9, but it's still 12 divided by 3 is 4. So this is going to be 4x cubed. 12 divided by 3 is 4. X to the 5th divided by x squared is x cubed. We'll do that one more time here too. 7x to the 6th y cubed over 2 times 7 x cubed y. So again, 7s here would cancel out, and we'd be left with x to the 6th divided by x cubed is x cubed. 6 minus 3 is 3. Y cubed divided by y is y squared, as in 3 minus that 1 right there is 2, all over 2. That's the simplified way to write that. We leave decimals out of exponential expressions. We try to write them as simplified fractions. Except for scientific notation. That's another story. So we got two numbers in scientific notation. We want the result to be in scientific notation. So the first thing I'm going to do is take this let's change colors. 3.2 divided by 8, and that's 0.4. And then I'll do the x to the 7th divided by x to the 4th, I'm sorry, 10 to the 7th divided by 10 to the 4th, and that's 10 to the 3rd. Now here's the one issue. That's not scientific notation, so I'm going to adjust that slightly and make this 4 times 10 squared, because we know that scientific notation, the first factor right here, has to be between 1 and 10 or negative 1 and 10. 0.4 doesn't fit that criteria. So all I did was multiply that by 10, and I divided that by 10. All right, what next? How about 5 cubed divided by 5? That would be 5 squared. A to the 6th divided by A, 6 minus 1 is 5. B to the 3rd divided by B squared, 3 minus 2 is B to the 1st, 1 right there. And, you know, I'm not going to leave that 5 squared. Normally I would just change that on the fly, knowing 5 squared is 25, but I wanted to show my steps. All right, what about over here? Well, let's do 6 divided by 2 first. That always has been and always will be 3. It's not that we're doing 6 minus 2. We only subtract the exponents. All right, and then we're going to do 5 to the power of, that's the base right there. They both have a base of 5. And what do we do with that base? We subtract the exponents. So x plus 7 minus 4. Obviously, that can be simplified. We'll write it as 3 times 5 to the power of x plus 3, because 7 minus 4 is 3. And that's really all we can do. Don't try and multiply that 3 times 5. We'd have to apply the exponent before we can do the multiplication. That's just order of operations. One more. Same base, x. What do we do with the bases, or what do we do with the exponents when we're dividing numbers at the same base? We subtract them. And in this case, 2b minus b is just 1b, or b. So that's x to the power of b. All right, then we got Cal over here, and Al. Cal's a little confused. He says that 3 to the 6th divided by 3 squared equals 1 to the 4th, because you divide the 3's and then subtract the exponent. So he's saying, oh, you do 3 divided by 3 is 1, and 6 minus 2 is 4. Well, if that was the case, wouldn't I do 7 minus 7, or 7 divided by 7 is 1 right here? But we already know that that's like 5 million. It's not 1 to the 8th. This is not 1 to the 6th. It's x to the 6th. So, Cal, that's just not true. So what do we tell Cal? I guess we could write it out for him in expanded notation. Maybe we do 3 times 3 times 3 times 3 times 3 times 3. There's 3 to the 6th, Cal. And here's 3 squared. And if we do those 3's divided by each other and those 3's divided by each other, we ended up with 3 to the 4th, not 1 to the 4th. Okay, so what should we say here? How about this? We'll say when dividing numbers with the same base, keep that base and subtract the exponents. That's the proper way to think about it. All right, we got Webster. He owns a set of antique dining room furniture that has been in the family for many years. The Historical Society tells him that furniture similar to his has been appreciating. That means going up in value at 10% per year for the last 20 years, and his furniture could be worth $10,000 now. Which letter in this equation could represent the value of the furniture 20 years ago when it started appreciating? So that is actually A. Let's go. Oops. Well, A is the initial value, we'll call it, initial value of the furniture. I'll even italicize that like they did. So A is the initial value, whereas Y is the current value, R is the rate of appreciation, and X is the number of years. Substitute the given information into the equation. Okay, so we know that it could be worth 10,000 now, so that's the current value. We're going to put that in for Y. We don't know its original value. And we know that the rate of appreciation is 10%. We'll put that in as a decimal. And that 20 years has gone by to cause it to be worth 10,000 right now. Okay, so there's our equation. Then it says solve that equation to find out how much Webster's furniture was worth 20 years ago. So that can actually be done in one step. To get a by itself, we're just going to divide both sides by 1 plus 0.10 to the 20th. So if we divide by that, we'll get a by itself. So we have to do it on both sides of this equation. We can put this into the calculator pretty easily too. 10,000 divided by 1.1, it's the same as 1 plus 0.1, to the power of 20. And that gives us that A is equal to $14,086.44. How about we just say about $1,500? I've seen other people, I mean, obviously we could do it like this too. We could do the 10,000 as the starting value, the initial value, and we could raise that to the power of negative 20. Does that give us the same value? It does. Look at that. I don't think that's really the way it was intended, but that is looking back with exponent, going backwards 20 years. All right. Next up, we're going to use the properties of exponents to rewrite each of these expressions. All right, careful with order of operations here. So I'm going to do 2x cubed. That's 2x times 2x times 2x. That's like 2 cubed times x cubed. All right. And then over here, this is 3x squared times 3x squared times 3x squared times 3x squared. That's what 3x squared to the fourth means. So it's going to be 3 to the fourth power. Oops, that's not right. 3 to the fourth power is 81. Let's try that again. I was doing 4 to the third power. And then x squared to the fourth power. X squared times x squared times x squared times x squared. That's x to the 8th. So we multiply the 2 times the 4. All right, so 2 cubed times 3 to the 4th is 648, just like 8 times 81 is 648. So 648 x to the 11th, because now we're multiplying numbers of the same base, x, so we add the exponents. There we go. Now there's an easy way to look at this one and a tough way to look at this one. Easiest way is to go, oh, these both have the same base, and that base is 5x. So I can just take that base, 5x, and subtract the exponent. 7 minus 5 is 2. And then square that would be 25x squared. That's the easier way to look at it. A lot of people might go, oh, that's 5 to the 7th on top, and that's 5 to the 5th on bottom. And you'd be right, but it's still 25. So, and then x to the 7th divided by x to the 5th is x squared. Keep going here. 2x to the 5th. Okay, so 2x times 2x times 2x times 2x times 2x. That's 2 to the 5th, which is 32. And then x to the 5th, which is x to the 5th. On the bottom, I'm not going to change anything quite yet. But now I can actually do the division. 32 divided by negative 8 is negative 4. X to the 5th divided by x cubed is x squared. Remember, you can assign any value you want in for x and check your original expression with your finished expression. Make sure they're equivalent, but kind of up against time, so we won't do that. All right, I'm not going to do anything with this first factor here because I need to do this third power right here first. So negative 3 to the third power. Now, that is negative 3 to the power of 3. Oops. Negative 3 to the power of 3 is negative 27. As in negative 3 times negative 3 is 9, times another negative 3 is negative 27. We've got this x being cubed, and we've got the y cubed being cubed. Y cubed times y cubed times y cubed. 3 times 3 we just do is 9. Now, we'll do 4 times negative 27 is negative 108. X squared times x cubed is x to the 5th, and y to the 5th times y to the 9th is y to the 14th. There is that simplified expression. X only appears once, y only appears once. We've got positive exponents. We'll talk about that more in a future lesson. And we only have one coefficient, the negative 108. All right, I think I'll approach this one a little differently. I'm going to use my exponent rules as much as possible here. 12 to the third power. I'm just going to leave that as 12 to the third power. I'm not going to even evaluate it. X squared to the third power. 2 times 3, we do 6. Down here on the bottom, I noticed that this 144, that's like 12 squared. Maybe, as you get better, you start to kind of see and look ahead at stuff like that. So 12 cubed divided by 12 squared, 3 minus 2 would be 1. So 12 to the first, x cubed. So by noticing that they both could be written as base 12, that saved me these huge numbers. 12 to the third is that number divided by 144. There it is. That's the 12. All right. Everything in these parentheses needs to be raised to the third power, but maybe I'll simplify first, because I noticed that a cubed over a, that can be simplified. I could simplify it now. I think I'll wait, though. I think I'll just do 4 cubed is 64. A cubed cubed is a to the 9th. 3 times 3 is 9. 5 cubed is 125. And a cubed is a cubed. And then I'll simplify. A to the 9th divided by a to the 3rd, we'll do 9 minus 3. So I'm going to write this as 64 a to the 6th over 125. That's how I'm going to write that. And I know that 64 over 125 cannot be simplified because 4/5 couldn't be simplified. So if I did simplify this, a cubed over a cubed to make it a squared cubed, we do the squared times the 3. 2 times 3, there would be my 6 right there. Next up, how about we just multiply first? Let's do 2x cubed times 15x. 2 times 15 is 30. X cubed times x is x to the 4th. And then all of that needs to be divided by 2x squared. 30 divided by 2 is 15. X to the 4th divided by x squared is x squared. 4 minus 2 is 2. One more. How about, I got to do that squared first. So I'm not going to change anything with this. But negative 2 squared is 4. Negative 2 times negative 2 is 4. A squared is a squared. Now I'll do negative 4 times times positive 4, and that's negative 16. A cubed times a squared is a to the 5th, and b to the 5th times b to the 0, I guess. We'll talk more about that in the future, is b to the 5th. So that is simplified. We have one coefficient, negative 16. A appears once with a positive exponent. B appears once with a positive exponent. That's what makes it simplified. All right, that's all I've got for you. A lot going on there. I'm sure number 5, you're probably finding some errors there. If you got questions about why I did the things I did, or you want to share things you did differently, I'd love to hear it. Have a great day. Mr. Kaczynski, out.